Hey everyone, so today we're going to talk about trapezoidal approximation method. So similar idea to RRAM, LRAM, and MRAM, which you did, which was rectangular approximation. Now instead of rectangles, we're going to be using trapezoids. So biggest thing you need to know here, area of a trapezoid, in case you forgot, is 1/2 times height B1 plus B2. Okay, so in a general sense, let's think about what's going on here for our trapezoids. How do we find height? How do we find B1 and B2? So the height of each trapezoid is actually going to be this delta x right here. Okay, so delta x, same thing technically as the height of your trapezoid, the distance between the bases. And the B1 and B2 is going to be that f of x at those two places. So like this would be f of x naught, this would be f of x1, whatever those values are at that point. And similarly, if you did the next one, it would be delta x, 1/2 delta x is your height. You'd actually have f of x1 again as one of your sides, and then you'd have this guy, f of x2, etc. So you could keep drawing here. The reason I'm using different colors, I want you guys to see those repeats. So what I mean by that is notice that we're actually using the same base a couple times. All those ones in the middle. So let's see here. Here. So you guys see those overlaps? So like this base got used twice, this one, and this one. The first and last were only used once. This is going to be important for us because we want to see how that's going to impact our equation. Okay, so first of all, no matter what, you can definitely find the areas of the trapezoid by doing each trapezoid. So one of our formulas could be 1/2 delta x, and you would do the height, or excuse me, base 1, which in this case it kind of looks like the height at y sub 0, and then plus base 2, which would be this other blue piece right here. Okay, plus 1/2 delta x, that would be 1/2 times height, base 1 plus base 2 plus 1/2 delta x times base 1 plus base 2, etc. So you'll see how this will keep going. We can finish writing it if you want. This is what we would use if you wanted to find each trapezoid. You could definitely do this. X sub 4, and last but not least, ran out of space, f of x sub 4 plus f of x sub 5. Okay, so there's your 5 trapezoids. 1, 2, 3, 4, 5 sub-intervals. That is how you would calculate it. Okay, what I want you guys to notice as you're writing, if you need to pause, go ahead. This is what we would do, and it will work no matter what because you're finding each trapezoid. But if you guys remember kind of when we did LRAM and RRAM, we tried to pull out delta x so that it was a little bit easier for us to calculate. So that's going to be the same thing here. So if we have equal intervals, equal subintervals, meaning every single delta x is the same, right? So delta x is, I guess you could say same or constant the whole time. All right, well then, if you factored out all these 1/2 delta x's, okay, you could put that in front, only multiply it once. And then what's going on the inside? Well, you'll notice we have f of x sub 0. That only happens once. Then you've got f of x sub 1, and you've got another one. Then you've got f of x sub 2, you've got another one. Same thing. So all those middle ones, like I showed you guys, those repeat. And then you'll notice, again, last but not least, f of x sub 5 does not repeat. So we could write this as 2 of the next one, 2 of x sub 2, 2 of x sub 3, 2 of x sub 4. But then last but not least, we only had one time when we used this piece right here because it was only involved in one trapezoid. So what I want you guys to see here, you've got the original side, f of x sub 0, 2 of the next one, 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 and only 1 of the last one. And again, you can see that from those overlaps. So this could be as many trapezoids as you want, right? I'm using an example with 5 trapezoids, but this could be a picture with 10 trapezoids, and you would use the middle 8 twice, and the first and last one would only be used once. Okay, just make a note to yourself. If it is not or unequal, I don't know why, well, we could say not equal, whatever. Not equal intervals, okay, you have to do each trapezoid because delta x is not the same for every single one. So basically you'd have to do something like this. All right. So we're going to try a little example here. 1 RRAM, 1 LRAM, and then a trapezoid. So this will be a little bit of review. Okay, so RRAM from 0 to 4, and all of these are 0 to 4, and we're doing 4 equal subintervals. So the nice thing is delta x will be the same for all of these. And delta x, remember we do 4 minus 0 over the amount of intervals, so 1. Okay, so each of these would be 0 to 1, 1 to 2. You could even move ahead a little bit. Let's just see the difference in our drawings as we go. Okay, so delta x is 1, that's good to know. The next thing we're going to do is figure out, okay, RRAM, you want to measure from the right side, and then the next one, right side over. Right-hand corner and right-hand corner. Okay, so again, each of those rectangles makes contact with the right side. All right, so when we do this, and again, if you were trying to figure out, am I going to use, those are my intervals here, 0 to 1, 1 to 2, 3 to 4. You're not going to end up using f of 0 since we're going to use the right-hand sides. Okay, so we could do delta x times, I'm sorry, this is supposed to be g of x, so I'll use the right letters here. G of 1 plus g of 2 plus g of 3 plus g of 4. Okay, you'd go to your picture. This is at 1. This is at 2.5. So let's write that down. Delta x was 1. G of 1 is 1. G of 2 is 2.5. G of 3 is 2. G of 4 is 3, right up here. Okay, add those together. We get 8.5. It would be our RRAM with 4 equal subintervals. Okay, let's see what's going on with LRAM. So again, we already know delta x is 1. If you were going to set up a little diagram here for yourself, 0 to 1, 1 to 2, 2 to 3, 3 to 4. Okay, we're going to be using 0, 1, 2, and 3 because we want to use those left sides. So up to the left, draw it over. Left-hand corner, draw to delta x. Left-hand corner and left-hand corner. Okay, so delta x times, this would be now g of 0 plus g of 1 plus g of 2 plus g of 3. Okay, and we'll say that we're at a quarter here, so 0.25. So delta x, this would be 1 times 0.25 plus, then we're at 1, then we're at 2.5, and this height is at 2. We add those all together, and we get 5.75. Okay, so that is RRAM and LRAM, little review for you there. And now we are going to do trapezoids. This will be the new one. Okay, so if you were to draw these in, which it would be a good skill to know how to draw these. Okay, you start here, here, and then you would connect with a straight line. So you could use that little notability tool. So we'll do this one. Make your 2 bases, connect. Sorry, I'm trying to make the lines a little bit next to each other so you can see 2 colors. It's not cooperating with me. There we go. And last but not least, right here, and then draw a flat line. Okay, so again, really what you're doing, you don't have to use any fancy formulas in the sense that you're finding the area of 1, 2, 3, 4 trapezoids, and you could just find those areas. Because we have delta x is the same for all of them, right? Delta x is equal to 1 since it was 0 to 4 with 4 equal subintervals. We can use our little shortcut. And by shortcut, I just mean this. So where we add the middle f of x values, there's going to be 2 of those. The ends only have 1. So 1/2 delta x times, again, we have 0, 1, 2, 3, and 4. So we have, sorry, this is g, I keep forgetting. G of 0, 2g of 1s, 2g of 2s, 2g of 3s, only 1g of 4. Again, that's because I used this side once, this side once. The rest of these middles I used in 2 trapezoids. I'm going to use this in 2 trapezoids, and I'm going to use this in 2 different trapezoids. So that's where that's coming from. And we end up with, let's see here, 1/2 times 1. G of 0 was 0.25 plus 2 times 1 plus 2 times 2.5 plus 2 times 2 plus 3. Okay, we add those all together, and you get 7.125. All right. Now, one good thing to notice, and you might already notice this, is that trapezoids and trap method here is a little bit more accurate than rectangles, right? It kind of gets the area a little bit more accurately. Specifically, it's actually the average of LRAM and RRAM. So it's kind of a fun fact to know and could come up and be useful. So whatever you get for LRAM plus whatever you get for RRAM, if you divide it by 2, you get whatever you're going to get for trapezoids. So that's exactly what just happened right here. So 8.5 plus 5.75 divided by 2, you end up with 7.125. So good little trick to know there, and a way to check your answer as well if you're doing the exact same intervals with delta x over the exact same a to b. So we're going to try one more together if you want to join me here on number 2. Okay, so without a graph now, but we have f of x given. We're going from -2 to 6 with a trapezoidal Riemann sum, Riemann approximation with 4 equal subintervals. So good news, we could find delta x because it's going to be the same for all. 6 minus -2 over 4 intervals. That gets us 2. Okay, so we start at -2, then we would go to 0, 2, plus 2, plus 2. So those are going to be the ends of our trapezoids. So we'll go from -2 to 0, repeat 0 to 2, repeat 2 to 4, repeat 4, and 1 of f of 6. All right, so again, first option, you could do 4 trapezoids separately. Next option, you could use this shortcut because we have equal subintervals. So that equation would be 1/2 delta x. We've got, let's see, f of -2 used once, 2 f of 0s, 2 f of 2s, 2 f of 4s, 1 f of 6 because it's only used in one trapezoid. Okay, and then we would just plug those values in for x squared plus 1. So this would be 1/2, delta x was 2. F of -2 would be 5, -2 squared plus 1, plus 2, f of 0 would be 1, plus 2, f of 2, 2 squared plus 1 would be 5. F of 4, 4 squared plus 1 would be 17. And f of 6, 6 squared plus 1 would be 37. So 1/2 times 2 would just be 1. 5 plus 2 plus 10 plus 34 plus 37, we end up with 88. And that's our final answer there. Again, your other option, if you didn't want to do this, just want to clarify, and actually we're going to do that right here. You'll notice 2 to 5 is not the same as 5 to 7. So we'll talk about what if we don't have equal subintervals. No matter what, you could always do this. 1/2 delta x, f of -2 plus f of 0. Close the parentheses. Next trapezoid, 1/2 delta x, f of 0 plus f of 2. Close the parentheses, plus 1/2 delta x, etc., etc. So you can do each trapezoid separately if that makes you feel better, if you just understand that more accurately. And also, if it's unequal intervals, we have to do that. If there's equal intervals, feel free to use this type of shortcut. But besides that, we'll save 3. On number 4, we've got a nice little application for that. And yeah, besides that, thank you so much for watching. Let me know if you have any questions.